Hi, and welcome to episode 24 of my free Java video course. My name is Markus Biel. In this episode, I'm going to take an in-depth look at ArrayList. In the second half of the video, I'll do a practical coding session. Okay, let's get started. ArrayList is a default implementation of the list interface. As with any implementation of list, you can have duplicate elements in your array list, and you can go from element to element in the same order as the elements were inserted. As it is based on arrays, ArrayList provides fast access, but inserting or removing an element at a random position requires more time, as this will require to reorganize the list. Fast access, however, is crucial for most applications, which is why ArrayList is the most commonly used collection. To store data that changes frequently, however, consider using an alternative container, for example linked list. I will talk about this as well as other containers in the upcoming episodes of my free Java video course. Okay, before I continue, let me introduce you to two different terms which are important to understand in context with ArrayList: size and capacity. Size is the number of elements the ArrayList currently holds. For every element you add to the list, the size will grow by 1. Capacity, however, is the number of elements the currently underlying array can hold. The capacity of the ArrayList grows in intervals. The ArrayList starts with an initial capacity. Every time you exceed the capacity of the ArrayList copies the data over to a new array that is about 50% larger than the previous one. Let's say you want to add 100 elements to an ArrayList of an initial capacity of 10. As the list grows, the system will create 6 more arrays to take the place of the first. First, one array that can hold 15 elements. Then one for a maximum of 22 elements. Then arrays with a capacity of 33, 49, 73, and finally 109 elements to hold the growing list. These restructuring arrangements can negatively impact performance. You can instantly create an array of the correct size to minimize these merging activities by defining the correct capacity at creation time. In case you don't know the final size of the array list at creation time, estimate it as close as possible. Choosing a too large capacity, however, can also negatively impact performance, so choose this value carefully. I advise you to always explicitly set the capacity at creation time, as it documents your intentions. For most projects, you won't have to worry about optimizing performance due to powerful hardware, but this is no excuse for sloppy design and poor implementation. Here you can see a simplified extract of the class ArrayList. Keep in mind, the real class looks a bit more complicated. This is just meant to give you a more concrete idea of what the class ArrayList looks like. As you can see, ArrayList is just a class anyone could have written, given enough time and knowledge. There is no black magic. You can find the actual source code online. However, don't rely too much on internals that you spot in the source code, as they may change any time if they're not defined in the Java language specification. Default capacity is the initial size of the array, when you don't specify it as I recommended before. Element data is the array used to store the elements of the array list. In size is the number of elements the array list currently holds. Get, add, and remove are some of the many functions ArrayList provides. We will look at those methods now. So let me give you a short overview of the methods of the ArrayList class. To make things easy for you, I have broken up the overview into methods belonging to the Java Util Collection interface and methods belonging to the Java Util List interface. When I talk about other containers in later episodes implementing the list or the collection interface, I will refer back to this episode, instead of repeating myself over and over again. Make sure you are subscribed to my YouTube channel, so you will be informed when I release episodes about these classes also. Okay, so let's start with the methods belonging to the Java Util Collection interface. The contract of the collection interface does not guarantee any particular order, and therefore does not provide any index or order-related methods. So here you can see the first set of methods that implement the collection interface. So what I say about these methods does not only apply to ArrayList, but also to all classes that implement the collection interface. The method boolean add appends the element to the end of the collection, to the next empty cell of the underlying array. Boolean add all appends all given elements to the end of the collection. The stuff in angel brackets is related to generics. In short, it ensures that no one can call such a method with the wrong arguments. For now, relax. I will tell you more in my upcoming episode about generics. Boolean remove removes the first occurrence of the element you specify from the collection. Boolean remove all removes the given elements from the collection. The iterator method returns an object you usually use in a loop to move from one element to the next element of the collection, step by step. You say, I iterate over the collection, hence the name iterator. Int size returns the number of elements of the collection. Boolean contains returns true if the collection contains at least one instance of the element you specify. Void clear removes all elements from the collection. Boolean is empty. This returns true if the collection contains no elements. And toArray returns an array containing all of the elements of the collection. Alright, let's move on to the methods of the Java Util List interface. The methods are similar in part to the methods we just looked at, but they differ in that they require an order on the elements of the list. So here again you should know that everything I say about these methods does not only apply to ArrayList, but to all classes that implement the list interface. This add method with an index parameter acts actually more like an insert method. It allows you to insert an element at any index position of the list, instead of just adding the element to the end of the list. In the process, the elements of the underlying array will be shifted to the right and migrated to a larger array, if necessary. The remove index method allows to remove an element from any index position of the list. Similar to the add method we just looked at, this might require to shift the remaining elements of the underlying array to the left. The getByIndex method returns an element from any given position of the list. The indexOf method takes an object and returns the index of the first occurrence of the element in the list, or -1 if the element is not found. Int lastIndexOf returns the index of the last occurrence of the element in the list, and as before, -1 if the element is not found. List sublist returns a view of the list starting with the position you specify as from index and ending one position before the one you specify as to index. Last but not least, The sort method sorts the list following the order of the given comparator. Alright, so let's end the lecture session. Time to move on to some practical coding. So now I'm in my IDE and you can see I have prepared a little test method so we can do some practical coding with ArrayList. I have already created an instance of ArrayList and I've assigned it to a reference variable of type collection. Now this might be a bit counterintuitive at first, because why is that not ArrayList or at least list? Well, there is a reason to it, and let me cite Robert C. Martin. He says, a good architecture is one that maximizes the number of decisions not made or the number of decisions deferred. And this is such a situation because by making this collection, I mean, you would create this instance for a reason, of course. And you probably would forward it to either other methods and or other objects. So now if you make this an array list, this will really limit all your other objects because they all only have to work on an array list. But now the requirements of your business, I mean, requirements usually they change very fast, as you know. And if they change, like for example, an array list can hold duplicate elements, but now there might be a new requirement that tells you you cannot have duplicate elements. You have to prevent that you have duplicate elements. So you might want to use hash set here. Now, if you used list or array list everywhere in the code, it will be very tough to change your mind. You will have to touch a lot of code, which is very dangerous. But if this is a collection can be so many things. And so it will be much easier to change your mind because all you will have to do is change the instantiation of the object that is actually being used. So if you can, like of course this limits the number of functions that you can use because the collection interface is less powerful than the list or the array list interface. But if you can, like if you only need the methods of the collection interface, well then do it like this. Later on, we will switch here to a list interface because I will also show you methods that only appear in the list interface, but we'll start with a reference variable of type collection. And then you'll also see the difference. Okay, what else can you see in this single line? Besides, you might spot that I've used generics in the angel brackets, so we have created a collection of type string. And here you might spot the so-called diamond operator that was introduced with Java 7. Well, because we do both in one line, we do the object instantiation and we create the reference variable in one line, the compiler directly sees this must be a string. And this is why here we can use the diamond operator, but we could also do it the old way by typing here string. This is just a bit shorter. Okay, and last but not least, you should notice here I wrote initial capacity, which is a constant, which I have defined here as private final int initial capacity 5. Now you might say, well, you could have also set just 5. I mean, this is faster. Well, at first it might seem so, but this is a so-called magic number, and this is evil, because it makes it so much harder for the next developer to know what this 5 actually means. Like, not everyone knows that an array list has an initial capacity, but if you use the constant value here, you document in the code your intentions. So this is actually quite good, and I recommend you to do it also. Okay, but now let's already start using some methods. I mean, I'm not going to properly program something, but we're just playing around with the methods so you get a better feeling of like what ArrayList is all about. And as this is now a collection reference variable, of course you'll only see all the methods of the collection interface. And we'll start simple with add. Of course, like one limitation that we have now is we don't see any index-based methods, which was also the reason why before in my slides I divided the methods into methods that are related to the collection interface and methods that are related to the list interface. Because now you can also go back to the slides and compare, because now we're doing the methods of the collection interface. So this is a collection of type string, so I can add a string. So let's add B, capital B. Let's add some more. A. Later on, I'm also planning to sort the array list, which array list allows. But right now, with the collection reference variable, we will not be able to sort it. But stay tuned, I'll do it soon. Okay. And I mean, even though we have a reference variable of type collection, still the fact that we have an array list influences that we can have duplicate elements. So let's do that. Maybe I should also add one A here. Okay. And now let's count how many elements I added. 1, 2, 3, 4, 5, 6. The initial capacity, however, is 5. So that means when you add the 6th element internally within the execution of this method, the array list will realize, well, the capacity is insufficient, will then create a new array of a larger size, and will then migrate all the existing data to the new array before the next element, the second E, is added, which costs some extra time. But really don't worry. I mean, in a regular situation like this, 5, 6 elements, the performance difference is ultra low. So never worry in such situations. This should really be only think about this when it gets a problem. And usually this could get a problem if you have like thousands or tens of thousands, if not a million of elements. So it always depends on the amount of elements you have, the amount of iterations that you do. Okay. So, and then we can also print the array list as it is now. There are two different ways. Array list has also a toString method, so I could directly say system out println elements, but I'm doing it a bit more complicated because I want to show you how we actually iterate over the array list. And this is because array list and array collection implements the iterable interface, which is used in this new for each loop. And so we can iterate over the array list by saying string, string, and then colon, and then elements. And what is required to iterate over this list will be done here inside, and you don't see it. This is all done by the compiler for us internally. In short, I can tell you there is an iterator method that I showed you shortly before, which will then be used. You might also check my last episode where I introduced you to the iterable and the iterator interface. Both will be used here. For now, I mean, it's enough if you see you can use the array list in the for each loop, and now we can print out each element separately, which of course gives us a bit more flexibility, like I could print something else here also. Okay. So this is called iteration, going over the collection element by element. And I also want to show you, let's comment this out. I also want to show you that, which is a feature of list, this order, how we added the elements A, B, A, C, E, E will be also exactly the same order as the elements are printed out, which would be different if we had a set. Okay, but enough of talking, let's already execute it and see it in action. Okay, so here you see A, B, A, C, E, E, exactly like we added that, which is a feature of list. Okay, now that we added elements, we could also remove some elements, which is also just as easy. Remove, and now on the collection interface I can't remove by index, but I can remove by stating the object that I want to be removed, which by the way internally uses the equals method. If you don't know about the equals method, I also have a video about the equals method. So it goes over each element and checks by using equals, which is implemented in the string class, if this A is equal to one of those elements here, and will then remove it. You might also notice I have two A's, so now it's interesting to know, like, will the first A be removed, will the second A be removed, or will both be removed? And there is another tip I have for you. Like, if you have such questions, you can look for a book, for a video tutorial, you can look in the API, and so on and so forth. But you will never be as sure, and probably also never be as fast, if you just write a simple test like this and you just try it out for yourself. I mean, how pragmatic, how cool is that? Because the code doesn't lie. If you see it, you will be sure that it behaves like you can see it. So let's do this and check which element is removed. And here you see B, A, C, E, E. So the first A is missing. So the answer is the first element is removed, not all A's are removed. Okay, so what else can we do? Let's check. We can also ask for the size. Let's make this a bit simpler now, to have it as short as possible. So now we have 1, 2, 3, 4 elements. I'll copy that. Copying some code that you will reuse is just safer not to introduce any typo. Okay. And as long as you're just copying the code and not duplicating the code, it's also fine. So this is supposed to give us the number of elements. Let me document this out so we just see the number of elements. Let's also do it directly after instantiation of the object. So I expect here to see a 0, no elements included. Or, I mean, this would be another alternative possibility that this would throw an exception if the list is empty. So let's check that. Execute the test. Well, it's actually not really a test, I'm just experimenting, but yeah. So you see, it returns 0 in the first line and then 4. So this is the size method. You can even ask, are you empty? Which should probably here say yes, true, and here probably false. And there it is, true and false. Okay. So let's now switch over to the list interface. And let's also play a bit around with that. You see, I have now a reference variable of type list, and I can use all the methods exactly like I used them before, because the list interface extends the collection interface, so it includes all the methods that the collection interface has. But on top of that, we now have more methods than just the methods of the collection interface. For example, I can insert an element by giving an index position. So I could, for example, say at index position 0, add me, I don't know, T. And at S at index position 2. And then let's use the simple, fast printout method. Let's remove this because it'll format the list in a one-liner. But let me just show you what I mean. Okay, we still have the true. We can also remove this. Okay, but for now it's fine. So we have t, because we added that at index position 0, which means this will be inserted where a was before. Before I added that at index 0, this was the index 0. So this put it to where a was before and then shifted everything else to the right. And this is why now this is nice to see it like this in one line, because you see this is all shifted to the right, which when I remove an element, the opposite happens. Like if I remove the s, everything will be shifted to the left. But let's see this later. Okay, and we added the s at index 2. So now this is index 0, 1, and 2, which again shifted the rest to the right. Okay, so let's also remove something. Let's do this here. Let's say I remove index. And now let's see, I remove index 1, which should be the b. Okay. And there it seems I am wrong because the a is still there. The b is still there. Let us see. Well, of course, because it's a bit confusing. As I added the t at index position 0, a is now index position 1, and this one was removed. So removing by index is always not so easy. Really, I have to tell you, these index-based methods, I hardly ever use them. Normally, you're fine actually with most of the methods of the collection interface, which again tells you, like, often it's a good idea to use collection here. Okay, so this actually inserts an element. Okay. By the way, let's increment this a bit, just for demonstration purposes. I mean, this is not so flexible. I mean, really, as I said in my slides, you should really think carefully the number of elements that you need. Just here it's different because we're playing around. Because I want to show you the difference again in an example between the capacity and the size. Because the size of the list is the number of elements. Let's do this here. And not the capacity. Because my array with a capacity of 100, the array will be 100 elements big, even though they're empty. But the size, however, will be much smaller. And here you see the size is 4 and not 100. So there is a difference. Okay. Now we can also ask for the index of a certain element. Let's do this here. Index of, and there is also last index of, and also is empty. Yeah, this we should also use. So index of, let's use the a. Yeah, which is, maybe we should remove that to not make it too confusing, to keep the a where it is. So now index of gets you the first index of an element. So I would expect that to be 0 now. Let's see this. And there you see 0. And we can also say last index of, which should be the second a. Let's check that. And you might ask, well, what do I need the index for? Well, you can use that to more flexible, like combine the methods. Now that you have the index, you could also say like remove this index or so on. I don't know. Might be helpful. Okay, so now I can also show you the clear method and the isEmpty method. I think the isEmpty method we already saw, but now let's use clear. This method is void, so I cannot print it, but I can put it here. Clear will empty the list, and then we'll ask, is it empty now? And we can also print out the list, an empty list, which is also interesting because this would be another question. Can I print out an empty list, or will this again throw an exception maybe? Let's test it. And you see, yes, it is empty and you can print it. It's just the square brackets and there's nothing in there. So this is an empty list. Okay, so I think that's already it. A really short introduction, some practical coding. I really recommend you to do the same, fire up your IDE or your text editor and play around with the methods of ArrayList. I know there are many more methods, of course. It's just that in this video I don't have all the time. So this is just meant to give you some motivation to play around with it by yourself. Okay. That's it for this episode. If you thought it was helpful, don't forget to hit the yellow subscribe button to get my newsletter. You will receive an exclusive bonus video and you'll be the first to know when I release new Java-related material. If you have any questions, leave them as a comment below this video. And please remember to give me a thumbs up before you go. Thanks for watching and see you next time.